Hello and welcome to a brand new section of this course, Numerical Optimization. In this section, we'll focus on numerical methods for solving continuous optimization problems. Many optimization algorithms are implemented in the scipy.optimize module. We'll come across other instances of optimization problems in several other sections of this course. Now let's move on to the first video of this section that deals with finding the root of a mathematical function. In this short video, we'll see how to use scipy to find the root of a simple mathematical function of a single real variable. Let's first import NumPy, scipy, scipy.optimize, and matplotlib. Next, we define the mathematical function in Python, f of x, and return np.cos of x minus x. So we'll try to find a root of this function numerically. Here, a root corresponds to a fixed point of the cosine function. Let's plot this function on the interval using 1000 samples with these lines of code. As you can see, we plot the function on interval minus 5,5 on 1000 samples. We see that this function has a unique root on this interval. This is because the function sign changes on this interval. The scipy.optimize module contains a few root-finding functions that are adapted here. For example, the bisect function implements the bisection method, also called the dichotomy method. It takes as input the function and the interval to find the root in. So this is the output. Let's visualize the root on the plot with this block of code. So the root is denoted. A faster and more powerful method is Brent Cue Method, or the Brent's method. This algorithm also requires f to be continuous and f of a and f of b to have different signs. Even this time, we have the same output. The Brent Cue method is faster than the bisect, which we used earlier. If the conditions are satisfied, it is a good idea to try Brent's method first. So let's check the time taken for execution using the timeitmagic command. timeitopt.bisect f, minus 5,5 and timeitopt.brentqf, minus 5,5. You can now clearly state the time difference between both the methods. So the second one, that is Brent Cue, is faster. The bisection method consists of iteratively cutting an interval in half and selecting a subinterval that necessarily contains a root. This method is based on the fact that if f is a continuous function of a single real variable, f of a greater than 0 and f of b less than 0, then f has a root in a b, that is intermediate value theorem. Brent's method is a popular hybrid algorithm combining root bracketing, interval bisection, and inverse quadratic interpolation. It is a default method that works in many cases. That's all for now.